Hi there, and welcome back to week 2 for CIS 258 data mining. I'm just going to provide a short lecture here, just kind of highlighting some things that you'll be going over this week. I'm not going to go through the PowerPoints slide by slide, but just kind of highlight some of the topics that you're going to be reviewing and making sure that you understand what the priorities are in terms of understanding the concepts. So under week 2, you'll notice under week 2 goals, in here, you're going to be covering three chapters in your textbook. The first chapter is on dimension reduction. The second chapter is on evaluating predictive performance. Chapter 14 is on association rules and collaborative filtering. In addition to that, I'm giving you the PowerPoint files for you to review. I've also provided some online websites for you to review that will go into more detail on classification accuracy measures and lift charts. There's some videos as well for you to watch, and then some homework assignments. So let's go through some of these real quick. Okay, so if I go through the week 2 text readings, you're going to be reading these 3 chapters. Really, the main things that you need to understand is really getting the proper terminology in your head. So for instance, dimensions. When you hear them talk about dimensions in your text or in any of the videos, they're actually talking about attributes in a data set. So they're the columns in the data set. That actually causes major issues for data mining if there's too many columns. It confuses, so to speak, the algorithms that you're going to be running against them. So sometimes we need to actually decrease the number of attributes that we're including in a data set. And usually number of records is not an issue. Actually, more data is better in that regard in terms of records, but in terms of columns, you want to only have things in there that are going to have the greatest predictive power. And there's various methods that we use to reduce data sets before using any of our algorithms when needed. The second chapter is going to really get into predictive performance, talking about different measures. The most common one that you'll see is accuracy, and it's the one that's most easily understood, but there's other ones as well that we're going to be talking about. And then in chapter 14, we're getting into association rules, which is actually for unsupervised learning, and collaborative filtering, which is related to association rules, but there are some distinct differences. Under the videos that you're going to be watching this week, you have a number of them. First, there's this one that I'm going through, which will be uploaded soon. You have a confusion matrix video. You actually have a homework assignment related to this, so this will be important for you to watch and make sure that you understand how it's constructed, and I'm going to talk a little bit about that here soon. Then we are going to talk about the curse of dimensionality, and this is going into why it's not good to have too many attributes in a data set. And these 2 videos should be very helpful to you as you are trying to understand that concept. Then under due, you have 2 homework assignments this week. The first one is from your page 102 on your textbook. It's problem 4.1. You're actually going to be using Excel Miner for this. I've provided solutions for you. This one's on breakfast cereals. If you have any problems with it, certainly let me know, and I'll be happy to provide any more videos explaining how to use Excel Miner. But I'd like to get your feedback first, and then I could quickly throw up some videos that is needed. But there's a lot of different charts you're going to be doing. You're going to be doing box plots, histograms, etc., and then answering questions based on those charts that you're creating. And then on 135 of your text, that's where it's going to be asking you to create a confusion matrix for a particular problem. And I'm going to talk a little bit about confusion matrices here shortly. The second homework assignment is using association rules. One, they're showing you on pages 333 and 334 of your text. They are actually going to be giving you the results of an association rule mining problem for cosmetic purchases. And you're going to be interpreting some of the measures that are associated with that. And then on the next, towards the end of that problem, you're going to be actually running Excel Miner and applying the associating rules to the entire data set, which I've provided in the homework assignment. Then from there, you have solution files down here. For anything that involves Excel Miner, I'm always providing you the solution files. You have the PDFs first that I give you of those Excel files so that you can view them. The other 2 are Excel files that will be opened up to once the assignment is due, so you can double check your work. So let's talk a little bit about classification accuracy. Accuracy, like I said, is the most common measure used in any kind of classification rules, decision trees, and some other algorithms. So anytime you're looking to classify a problem, which is supervised learning, so you're trying to predict something, you know what it is you're trying to predict, and you have data, historical data, that shows how things have been predicted in the past. So you can get classification accuracy very easily, usually from a confusion matrix, which I'm going to show you down here. Let me scroll down a little bit. So this is showing CART, which is a type of classification algorithm. And you can see here, the way you read this is you have at the top recurrence and no recurrence, which is referring to what a particular record was classified as according to the model. So it's predicting. So this is your your testing data. When you do your testing data, this is what the results are giving you. This is what it actually was. So basically it's testing how well did this model predict on your testing data the results. So the way you read this is it's a truth table. So 10 here is saying that there was 10 records that actually had recurring breast cancer, according to this problem, and the model correctly classified them as being breast cancer. So 10 were correct. Over here under no recurrence, this 188 value is saying that there was 188 records there where breast cancer did not recur, and the model was able to correctly classify it. And then these are the errors across this diagonal here. So in this case, there was recurrence, but the model said there wasn't recurrence. And in this case below, no recurrence, there were 75 that it classified as recurring when actually there was no recurrence. So to get the accuracy for this, I'm going to bring up my calculator here. You're going to want to take the diagonal of 10 plus 188, which is 198 records, divided by the total number of records. So the total number is 85 plus 201. That's 286. So I'm going to take that 189 divided by 286. That's giving me 66% accuracy on this. The one thing that's important to note here is 66% accuracy is actually, it's not bad. 80% would be better. But what it's saying is that we need to pay attention to the false negatives and the false positive. False negatives in this case were 75. So this is where in a breast cancer problem, you had basically women who really, if this was going to be used as a model, there would be women who were never going to have a chance of recurrence, but were going through additional tests and treatments. So that's called a false negative. A false positive would be over here under 13, where there was a recurrence, but the model predicted it as not recurring. That's actually a problem. So that means it's going to miss women. Women who should have been treated are not going to be treated. And particularly in medicine, these false positives and false negatives are actually very, very important. And it's also called, the other measures are called sensitivity and specificity. It's actually the same thing as this, but it's a different name in the medical terminology. So this is another way of looking at accuracy, beyond accuracy in some of these classification models. The other thing we're going to look at is lift charts. And in this website here that I gave you the link for, you'll see that it's going through exactly how it's figuring out the lift charts. What I want you to really understand is up here, is it says basically lift is a measure of effectiveness of a predictive model calculated as a ratio between the results obtained with and without the predictive model. It gives you a visual aid for measuring the model performance. So it has a baseline and it has a lift curve. The way you read this is the greater the area between the lift curve and the baseline, the better the model. So if I go down to one of these models here, you can see this is the baseline is in the pink, and then in the dark blue is this lift curve. You can see how much area there is between the two, so it's showing that there is actually a pretty good response. This model is able to significantly change from the baseline. If this line was closer to the pink, that would show that it was not as effective. Here's another example of a lift curve and baseline. You can see that it is actually working fairly well when it's at 10%, but as you increase the number of customers that you've contacted, it's not making a difference. So there's kind of a diseconomies of scale going on in here. Basically, you don't want to over contact your customers, otherwise you're not really getting much reward from it. And you can go through this and see how they're actually calculating this out. You're not expected to know that for any exams, but I just want to make sure you understand how to evaluate these curves when you see them in any of your results. So again, as you go through materials, if you have questions, especially on the homework, please let me know when you get to the homework assignments. If you are struggling with anything in Excel Minor, please let me know what you're struggling with. I'd be happy to create a quick video or find a video online that will help you with this. But I'm going to let you try it first along with the solution files. And then if you have issues with this, please let me know what they are, and I'll be happy to help out. Hope you have a good week. Thank you.